Welcome to the Mahatma Gandhi Institute of Technical Education and Research Center. In 2004, a national level institute AMGITA has been started in the field of engineering and technology as per guidelines of All India Council for Technical Education AICTE New Delhi. AMGITA is approved by AICTE New Delhi, Gujarat State and affiliated to Gujarat Technological University Ahmedabad, which is also known as GTU. Our goal is to be an institute of generative ideas so that we remain relevant to our society. The AMGITA has always been an organization on move with continuous effort on improving its processes and to maintain its relevance to the Indian science scenario, with adding new programs in its programmatic portfolio. We strongly believe in overall development of students, so for that we provide them a different platform like state level tech fest, project fair, different sports activity, which helps students to teach teamwork and problem solving skills to get physical health benefits, boost self esteem, and reduce pressure and stress for prove their skills in distinct area. Welcome students to the lecture of electrical measurements and measuring instruments. Myself Professor Gaurang Patel from Mahatma Gandhi Institute of Technical Education and Research Center, Navsari. So students, we are going to discuss in today's lecture section about the chapter number 2, transducer and sensors. Okay, so in this lecture we will going to recover these topics. I will just show you. So these are the points to be covered in this lecture. First of all, we will going through the characteristics of the transducers. What are the characteristics of transducer? We will discuss in detail. Then we will see what are the general characteristics of the transducer, and then we will go towards the dynamic characteristic of the transducer. So that much portion we are going to cover in this video lecture. Okay, students. So we will start. Okay students, so we will start where we left from in last lecture. In today's lecture what we are going to cover, that is characteristics of transducers. Okay, so students, what we are going to learn in transducer, so basically what is the definition of transducer? I had told you so many times कि भाई transducer क्या बेसिकली करता है हमारे इलेक्ट्रिकल इंजीनियरिंग में, कि वो नॉन इलेक्ट्रिकल क्वांटिटी को इलेक्ट्रिकल क्वांटिटी में ट्रांसफ़र करके हमें बताता है कि ये उसकी अमाउंट कितनी है. ओके, फॉर एग्जांपल हमें अगर किसी कोई डिस्प्लेसमेंट काउंट करना है इन टर्म्स ऑफ इलेक्ट्रिकल सिग्नल, then it will shows in electrical signal that how much displacement is going to be covered. Okay, and for that we have taken certain examples for that lecture. In that lecture, that is the example of strain gauge, LVDT, linear variable differential transducer. Okay, so how they were going to be operated, I explained to you in that lecture as well. So today we are going to learn about the characteristic of transducer. Just a moment. Pritesh Patel is there. So I 8 students are there. I will take your attendance in last session. Okay. So now, what is characteristics of transducers? So first statement, that is there are three characteristics of the transducers which are very important for the point of view of the selection of the transducer. So these are as follows. First of all, that is input characteristic, then output characteristic, and the transfer characteristics. So three characteristics are given over here for the transducer कि भाई उसका इनपुट कैसा होना चाहिए. ओके, देन एज पर द इनपुट what is the behavior it will give you at the output, and what will be the transfer rate of that particular signal. Okay, so first of all we will go towards the input characteristics. तो क्या दिया गया है input characteristic में? So type of input and operating range. Okay, so type of input and operating range. Now we will see the most consideration for the choice of a transducer is the input quantity which is going to be measured and its operating range, and the type of input which can be any physical quantity that is generally determined in advance. Okay, Now, a physical quantity may be measured through use of number of transducers. However, the choice of particular transducer that is selected for the purpose depends upon the useful range of input quantity over which the transducer can be used, and the useful operating range of the transducer may be a decisive factor in selection of a transducer for a particular application. Okay, so what it want to say in the input and operating range, that means whatever जो भी हम ट्रांसड्यूसर यूज कर रहे हैं वो हम यूज करेंगे एक पर्टिकुलर रेंज के लिए. ओके, वॉट एवर द फिजिकल क्वांटिटी इट मे बी देयर. फॉर एग्जाम्पल इफ हम हमें कोई मास मेजर करना है, ओके, तो उसके लिए जो भी हमारा ऑपरेटिंग इंस्ट्रूमेंट हो वो उसका एक पर्टिकुलर रेंज होगी. ओके, कि भाई 10 kg का मास है तो वो 10 kg तक ही हमें उसका सिग्नल कन्वर्ट करके देगा. ओके, सो इट इज प्री डिफाइंड, इट इज ऑलरेडी प्री डिफाइंड हाउ मच इट विल बी गोइंग टू बी measured. Okay, then next one, that is the loading effects. Okay, what is the loading effects on the characteristic of transducer? That is, now we can see that is ideally a transducer should have no loading effect on the input quantity being measured. In theory it is impossible, although in practice steps may be taken to reduce the loading effect to negligible proportions. तो इसमें क्या कहते हैं स्टूडेंट्स के जो भी ट्रांसड्यूसर है उसमें इनपुट साइड पे उसकी कोई भी लोडिंग इफेक्ट्स नहीं रहेगी, क्योंकि बेसिकली ट्रांसड्यूसर क्या करता है कि जो नॉन इलेक्ट्रिकल सिग्नल है उसको इलेक्ट्रिकल सिग्नल में ट्रांसफर करता है और उसके लिए वो एक बीच में दूसरा कन्वर्जेशन स्टेट यूज करता है. सो जो भी लोडिंग इफेक्ट्स आएगी वो उन कन्वर्जेशन स्टेट पे आएगी, ना कि उसके इनपुट साइड पे आएगी. ओके, सो the second statement says that the magnitude of the loading effects can be expressed in terms of force, power, or energy extracted from the quantity under measurement for working of the transducer. Okay, student, just a moment. I will just try to make this right. Okay, so I am visible to you guys.
Yes, sir.
Now, next we will see, therefore the transducer that is selected for a particular application should ideally extract no force, power or energy from the quantity under measurement in order that the latter is measured accurately. So what it will try to say is us, that is, whenever we are going any input to the transducer, that will not going to be affected at the output characteristic of the transducer, because whatever energy we are going to transfer, that is, if suppose that is if we want to transfer this energy of force or power, that quantity under measurement in order that the later is measured accurately. Okay, now we will switch over to the output characteristics. Okay, so I will just make it, grab it over here. So what is the output characteristic? Three kinds of output characteristics are given over here. That is, first, type of electrical output, output impedance, and useful output range. Okay, now which kind of electrical output it will be given? Okay, which kind of electrical output, that means कि भाई हमारा जो ट्रांसड्यूसर है, हम जो ट्रांसड्यूसर यूज कर रहे हैं, ओके, वो कौन सी टाइप्स का है, आइदर इट इज एनालॉग transducer or either it is digital transducer. For example, if it is an analog transducer, so it will, there is a pointer over there, and that pointer is deflected and it will give you the output according to the deflection. Okay, तो हमें वो रीड करना है और फिर हमें पता चलेगा कि भाई कितना आउटपुट पर्टिकुलर हमने मेजर किया है. ओके, either if it is a digital transducer, so it will give you the output in form of digits. Okay, so that is the output characteristic of electrical output. Then what is the output impedance and what is the useful output range, then we will see of that. So over here, this first, we already discussed that type of electrical output, which kind of output it will be measured. in that transducer. Then we will see output impedance. Okay, so output impedance, that means the output impedance Z0 of a transducer determines to the extent the subsequent stages of instrumentation is loaded, and ideally the value of output impedance should be 0 if no loading effects are there on the subsequent stage. Now what it will be say, the value of output impedance should be 0. अगर आउटपुट में उसको ज़्यादा impedance मिलेगा तो क्या होगा कि भाई जो भी हम चीज़ें मेज़र कर रहे हैं उसके मेजरिंग रिजल्ट्स में भी इफेक्ट्स आएगा. ओके, फॉर एग्जांपल अगर हम कोई क्वांटिटी का वोल्टेज मेजर कर रहे हैं इन टर्म्स ऑफ वोल्टेज, इफ वी आर ट्राइंग टू मेजर द वोल्टेज एंड इफ वी आर हैविंग अ इम्पीडेंस ऑन द आउटपुट साइड, तो उस इम्पीडेंस के वजह से क्या होगा, थोड़ा लॉसेस हमें मिलेगा और उस लॉसेस के वजह से जो एक्चुअल रीडिंग है वो हमें नहीं मिलेगा. ओके, सो इन द आउटपुट योर इम्पीडेंस शुड बी 0 or it should be no loading effects. Whatever the load you are connected with your transducer, it is having its minimal effect should be there. Okay, now in this statement, it is given the output impedance determined by the amount of power that can be transferred to the succeeding stages of the instrumentation system for a given output signal level. And the last one is that is given, if the output impedance is low as compared to the forward impedance of the system, the transducer has the characteristic of constant voltage source. Okay, while in case of forward impedance is high as compared with the output impedance of transducer, it behaves in constant current source. So what it will be behaved, if there is an output impedance is higher, it will be behaved as a, वो कैसे behave करेगा, constant voltage source की तरह behave करेगा, और if it is lower that it is behaves as a constant current source. Okay, now the third one, that is the useful output range. So students, in useful output range, what they are want to say us, that the output range of a transducer is limited at the lower and by noise signals which may protect the desired input signals, and the upper limit is set by the maximum useful input level. Okay, so output range, that means how much output we can measure through the transducer in terms of the input. Okay, so the output range can be increased in some case by the inclusion of amplifier in the transducer. However, the inclusion of an amplifier also increases the noise level, and therefore in such situation the amplifier may not be any use at all. So हम output range को बढ़ा सकते हैं with the use of amplifier if it is needed. Okay, but consequences उसके क्या रहेंगे, अगर हम output range को बढ़ाएंगे amplifier through, तो losses ज़्यादा होने के chances हो सकते हैं. Okay, so these all are the characteristic of the transducer. So basic, there are three characteristics, that is type of electrical output, output impedance, and useful output range. So in nutshell you can say that if this kind of questions asked in your examination, so if it is in 2 or 3 marks, then you don't have to write all of the theories in that and don't waste your time of that. Just put when an important statement regarding each and every point. Okay, and what are the important statement that you guys you can easily extract from this explanation, that is, if type of electrical output, that means either it is in form of analog or digital. Output impedance, so it should be a lower at the output side, and output range, that we can increase the output range but with the facing the consequences. Okay, so such kind of answer you can given in the examination. If it depends how much how this question is asked, and it is asked for how many marks. Okay, now we will see the transfer characteristic of the transducer. Okay, now for the transfer characteristic transducer, they are given transfer function, error, and transducer response. Okay students, so first of all we will go with the transfer function. So what is transfer function basically? Okay, so it is given over here, the transfer function of a transducer defines a relationship between the input quantity and the output. Okay, हम कोई भी अगर ट्रांसफर फंक्शन ले ले तो वो बेसिकली क्या है, ट्रांसफर फंक्शन कि वो एक रिलेशनशिप हमें डिराइव करके देता है कि भाई आउटपुट और इनपुट के बीच में रिलेशनशिप क्या है, तो वो हम ट्रांसफर फंक्शन से डिफाइन कर सकते हैं. फॉर द ट्रांसफर फंक्शन Q0 is equal to f of Qi, where Q0 and Qi are respectively output and input of the transducer. So Q0 क्या है यहाँ पे, that is the output of the transducer, and Qi, that is nothing but the input of the transducer. I stands for input and O, that is stands for output. You can see those term that is given in that suffix. So now from that, the sensitivity of transducer is defined as the differential quotient. Okay, now how much sensitivity of the transducer, that is we can denote it with the S. Sensitivity S is equal to dq0 by dqi. So out, that is in terms of output divided by input. Okay, so now in general the sensitivity of transducer is not constant but is dependent upon the quantity Qi. Now students, now what these statements want to say us that sensitivity of transducer is not constant. Okay, but now what is sensitivity? We discussed this term sensitivity, that means how फास्ट योर ट्रांसड्यूसर गिव यू एन आउटपुट. ओके, कि भाई हमने कुछ भी इनपुट, जो भी हमारा कांस्टेंट एक इनपुट हम उसमें दे रहे हैं, तो थोड़ा सा भी अगर उसमें चेंज आया तो आपको वो कितने एक्यूरेटली बता देगा. दैट इज द सेंसिटिविटी ऑफ द ट्रांसड्यूसर. एंड you can say that sensitivity of transducer is not always constant. Okay, because by the time whatever the instruments you are going to use, हम जब चीज़ें हम यूज़ करते हैं, so उसका जो भी सेंसिटिविटी फैक्टर है, जो भी सेंसिटिविटी है, जो इनिशियली जो होगा उससे थोड़ा थोड़ा आफ्टर बीइंग लॉन्ग यूज इट विल बी गोइंग टू बी डिटीरियोरेटेड. ओके, ड्यू टू द मैकेनिकल वेयर एंड टेयर. बिकॉज in transducer there are certain mechanical instrument are also we are using in that mechanical parts are there in the transducer, because you can see there is a spring. Okay, there is a magnetic field that we are going to use. Okay, there we are going to use a coil in the transducer. So after long usage of time it will having their lower working with the quite lower efficiency. Okay, so that's why we can say that sensitivity of transducer is not constant, and it is the and sometimes the atmospheric effect is also will be there, it is also affected to the transducer. So that is says that it is not constant but it is dependent upon the quantity Qi. Okay, Qi that is nothing but the input, जो हम input दे रहे हैं उस पे भी वो depend करता है. Okay, now over here, however, in some cases the relationship between the output Q0 and input Qi is linear. Okay, in that case the sensitivity remains constant over the entire range of the transducer, and it is defined as, if you define the sensitivity is constant, that dqo divided by dqi, that means output by input is equal to output by input. So that is in terms of change, this term is given as in terms of change if it is varied. And now what we are assuming, now it is constant. So here we can say this is the symbol of derivation. So s dash is equal to q0 by qi, हम इसे इस तरह से भी लिख सकते हैं. Okay, now the scale factor is defined as the inverse of sensitivity and is therefore scale factor is equal to 1 by s and is equal to dqi by dq0. Now some manufacturers specify the scale factor and still call it sensitivity. So students, if you want to say what is the sensitivity and what is the scale factor, so you can easily understood by these definitions. Okay, or by this equation, that is scale factor is equal to 1 by s, and that is nothing but the whatever the changes in input with related the whatever the changes in output. Okay, so that you can easily understood with from this equation. Okay, now we will switch over to the error. Okay, now error, that means in everywhere in every instrument you will definitely get the error, because there is a different kinds of error that we were already discussed. There are different kinds of error: human error, gross error. Okay, the error is happening by time being used with the instrument. हम जितनी इंस्ट्रूमेंट को यूज करते हैं, जितने टाइम हम उसको यूज करते हैं, तो आफ्टर लॉन्ग टाइम इट विल गिव यू एन एरर with the instrument. Okay, now first point, that is the error in transducer occur because they do not follow the input output relationship given by output is equal to f of q I. Okay, because the first statement what is says that it will not follow the input output relationship. Okay, now any departure from the above relationship results in error. Definitely अगर वो प्रॉपर फॉर्मेट या प्रॉपर रूल्स रेगुलेशन फॉलो नहीं करेगा कोई भी चीज में, नॉट इवन इन अवर ट्रांसड्यूसर, वॉट एवर द मशीन्स दैट we build for the perform for the particular task from particular way, if it will not perform in that with that rules, then definitely it will gives you an error for this particular function. Okay, so any departure from the above relationship results in error. That is, it says कि भाई इस अगर ये follow नहीं कर रहा है तो definitely it will gives you an error. And what is error? That is q0 by q. So that is the change q0, that is giving the change, and that is the constant output. So error, that is your whatever the change in output minus whatever the output you will get at the end. So the error it can be expressed in terms of either input or the output क्वांटिटी. हम एरर को कैसे एक्सप्लेन कर सकते हैं? या तो हम हमें इनपुट क्वांटिटी के रिगार्डिंग, आइदर हम उसको आउटपुट क्वांटिटी के रिगार्डिंग एरर को मेजर कर सकते हैं भाई कितना हम इनपुट दे रहे हैं, ओके, और कितना हमें आउटपुट मिल रहा है. सो हम आउटपुट माइनस इनपुट करके उसको वट एवर द लॉसेज दैट occurred in that particular machine or in that particular transducer, we can easily measure the error from this equation. Okay, now the error can be split into three components, which are scale error, dynamic error, and error on account of noise and drift. So these three things we will see. That is, scale error is given over here. What is the scale error? The scale error comprises of four different types of errors. That is zero error. Okay, in this case the output deviates from the correct value by a constant factor over the entire range of the transducer. So in zero error में क्या होता है कि भाई आउटपुट जो है वो थोड़ा डेविएट करता है फ्रॉम द करेक्ट वैल्यू, जो भी करेक्ट वैल्यू आनी चाहिए उससे थोड़ी सी वैल्यू उसकी डिफरेंट आती है. ओके, इन जीरो एरर मेजरमेंट में. Okay, so this is the graph is given for the transducer zero error. At the horizontal side, that is the input is given over here. Here, that is the output is given on the x-axis, and y-axis given the input. Okay, so in input and in place of output is there one line that is constantly or linearly going upwards, that is the theoretical curve. कि भाई एक्चुअल कर्व क्या है? theoretical हमें इतना एरर मिलना चाहिए कि जितना भी हमें इनपुट यहाँ से हम वेरी करो उतना ही आउटपुट में भी चेंज आना चाहिए. ओके, बट you can see that is practical curve shows you a different result. Over here you can see there is a practical curve that gives you a different result. Okay, this is the practical curve you can see over here. So actual curve हमें इतना मिलना चाहिए, but on the line of zero it will give you, यहाँ पे input zero है फिर भी output में हमें कुछ इतनी errors आ रही है. So it will not gives you a linear output. So that is the consider as a transducer zero error. Okay, now for the sensitivity error, you can see the sensitivity error. Now sensitivity error occurs where the observed output deviates from the correct value by a constant factor. Suppose the correct output is q, then the output would be kq over the entire range of the transducer where k is a constant. This is shown in figure. Now whenever you take the sensitivity error, now you will consider this graph once again. On x-axis that is the input is given, and on y-axis that is output is given. Now this is the theoretical value for the sensitivity error. This should be the error as per the theory. Okay, but what we will get, the practical value is we will get, if you see, it is not as per the theoretical value, because in real practice there are so many factors is going to be affected for the sensitivity of that particular transducer. Okay, so this you can consider as a transducer sensitivity error. Okay students, now next we will see that is non-conformity. Non-conformity, that means there is nothing you can say that the things is going to be happen in that way, that particular way. So you cannot predict any particular statement, or you cannot say any particular रिजल्ट दैट यू विल बी अचीव्ड इफ सपोज कि भाई मैं इतना इनपुट दे रहा हूं तो मुझे पर्टिकुलर इस टाइम पे उतना ही आउटपुट मिलेगा। ओके, और और आप क्या कह सकते हैं कि भाई नॉन कन्फर्मिटी मीन्स यू कैन नॉट से एग्जैक्टली what it is going to be happen। okay, now the statement that is non-conformity given over here, this is the case in which the experimentally obtained transfer function deviates from the theoretical transfer function for almost every input. This is shown in figure. So you can see for every input it is going to be deviated. Okay, in the special case of theoretical linear relationship between input and output quantities, this error is called non-linearity or non-linear distortion. You can see there is no linearity is going to be happen if you compare in between input and output at any given time. Suppose if you this should be your theoretical value, but this will you get at the practical value। अगर आप इनपुट और आउटपुट को कंपेयर कर रहे हैं किसी भी पर्टिकुलर टाइम पे, सो इट विल नॉट बिहेविंग व्हाट वी आर गोइंग टू अज्यूम, और हमने जो डिसाइड किया है वो उस तरह से नहीं बिहेव कर रहा है। दैट इज नॉन एज द ट्रांसड्यूसर नॉन कंफर्मिटी। सो दिस ग्राफ shows you the transducer non conformity। okay, now we will see what is the hysteresis। now all transducers are subjected to the effect of hysteresis। okay, and the output of transducer not only depends upon the input quantity but also upon input quantities previously applied to it। okay, so students, it is not depend कि भाई हम right now क्या input दे रहे हैं। okay, इट इज ऑल्सो डिपेंड्स कि हमने प्रीवियसली उस पर क्या इनपुट दिया था उसकी वजह से उसमें क्या चेंजेस आया था। दैट मीन्स व्हाट चेंजेस it was happened when previously we were given the input। suppose for example हमारा एक वोल्ट मीटर है जो 230 वोल्ट मेजर करने के लिए बनाया गया है। ओके, सो नाउ व्हेन वी आर अप्लाइंग, इफ वी अप्लाइंग मोर देन 230 वोल्ट, सपोज हमारा वोल्टेज बढ़ गया और मोर देन 230 वोल्ट से ज़्यादा कुछ उसमें हमने इनपुट दे दिया, सपोज 280 290 वोल्ट, सो उस टाइम वो कंप्लीटली डैमेज नहीं हुआ होगा, लेकिन उसके उसके जो पार्ट्स है उसमें कुछ ना कुछ तो इफेक्ट आया होगा। ओके, तो उस इफेक्ट की वजह से उसका परफॉर्मेंस नाउ इट इज गोइंग टू बी डिटेरियोरेटेड व्हेन यू आर इवन गिविंग योर करेक्ट इनपुट। ओके, what so that's why it is says that whatever the input you give previously, that is also affected the at this time as well। okay, now what it is says, a different output is obtained when the same value of input quantity is applied depending upon whether it is increasing or decreasing। for decreasing values a greater output is obtained than with increasing values for the same value of the input quantity, this shown in figure। okay, so what this graph is says to you student, I will just show you। ये ग्राफ आपको क्या बता रहा है कि भाई हमें कभी ऐसा लगता है कि हमने पहले एक पर्टिकुलर 10 वोल्ट पे हमें इतना आउटपुट मिला था, वापिस हम थोड़ी टाइम के बाद दूसरी बार 10 वोल्ट दे रहे हैं तो हम ऑब्वियसली ये सोचेंगे कि हमें वापस उतना ही वोल्टेज आउटपुट में मिलना चाहिए, बट इट इज नॉट लाइक दैट। व्हाई? बिकॉज इट वाज ऑलरेडी अफेक्टेड, बिकॉज हमने प्रीवियसली इन पास्ट में उस इंस्ट्रूमेंट को थोड़ा सा डैमेज किया हुआ है। कैसे कि भाई एडिशनल वोल्टेज दे के। ओके, तो इंटरनली उनके जो इंस्ट्रूमेंट है दैट वाज ऑलरेडी being affected that we are not knowing। okay, so that's why it will not give you the exact output each and every time as for the same input। okay, so that is the graph it is given over here, that is also known as transducer hysteresis. Okay, in that graph you can see on the x-axis input is given, and that is the output is given on the y-axis. So when it is starting from the zero, when you vary the input, okay, now it will come along over there. Okay, now at that time when you increasing the input, what will be the result of output, you can see over here. Okay, इतने इनपुट पे भाई हमारा ये आउटपुट आ रहा है. ओके, ये पर्टिकुलर इस टाइम पे. नाउ व्हेन यू आर सेम लिनियरली डिक्रीज द इनपुट, ओके, यही अमाउंट यही टाइम पे इतना ही इनपुट है, फिर भी योर आउटपुट इज गोइंग टू बी, यू विल गेट इट देयर. समझ में आ रहा है आपको कि एक्चुअली क्या होना चाहिए कि भाई हम डिक्रीज कर रहे हैं इनपुट को, वापस हम वापस यहाँ से पीछे आ रहे हैं, तो सेम लिनियरली ये जो लाइन है, ये वाली जो लाइन दी हुई है, वो वापस इसी तरह से कम होनी चाहिए. ओके, बट इट इज नॉट हैपेंस because you will get the different line over there. That means with the same amount of input, you will not get each and every time the same amount of output. Okay students, so that is known as the transducer hysteresis. Okay, now we will see what is the dynamic error. Okay, now dynamic error, that is, what is the dynamic error? That is, dynamic errors occur only when the input quantity is varying with time. Okay, now if the input quantity is varying with time, you will get the dynamic error, and this is on account of the fact the system contains energy storage elements, and due to this the output cannot follow the input exactly but with a time lag. Okay, now once again there is a fundamental of electrical is going to be applied, because whatever the electrical instrument that we are going to use, there it is having use so many components, they are storing the energy. For example, you are using the inductor, you are using the capacitor. So what is the function of all that? They are storing the energy. Suppose capacitor you are use that it will store the your voltage, and if inductor you are going to use, it will store your करंट. ओके, सो नाउ इफ यू थिंक भाई हमें अब ऐसा लग रहा है कि भाई सेम आउटपुट पे सेम इनपुट क्यों नहीं मिल रहा है, क्योंकि ये जो एलिमेंट्स हैं वो भी कुछ एनर्जी स्टोर कर रहे हैं, तो वो सेम टाइम पे आपको वही चीज नहीं देंगे. ओके, इट विल take some time, so output is going to be lag due to that storage element you are going to be used in that particular instrument. Okay, now let us consider an RC series circuit to which a step input of a magnitude E is applied, and the voltage across the capacitor after a time t of application step input is. Okay, so over here there is a dynamic response is given for the transient plus steady state. Once again you can see there is the practical value that you will be get over here according to the output voltage. Okay, so there is the dynamic response, you can see over here, as the time is being over here, time is increased, your output voltage is going to be changed with respect to time. Okay, and that is over here, this voltage is given is at that time, this particular constant voltage you will be get, and this is the minimum gap you can achieve at that particular level. Okay, so that is it, you can consider as a dynamic error. Okay, so this all about the errors happens. One more error that is given, errors due to the noise and drift. Okay, whatever the noise, that means noise and drift signals originating from the transducer vary with time and are superimposed on the output signal. Okay, just a moment student. Okay, so noise and drift signals originating from the transducer vary with the time and are superimposed on the input signal. Now the difference random frequency while drift is a slow change with time, and the magnitude of the noise and drift is normally independent of the magnitude of the input signal. So noise and drift, that is normally independent to the magnitude of input signals. Okay, now third one, that is the transducer response. Okay, just I will see what is the transducer response, and it will be the last topic of today, student, transducer response. Okay, after that we will finish this lecture. Okay, now transducer response. The response of the transducer to environmental influences is of a great importance. Okay, because what it will be said, the response of transducer to environmental influences is of great importance. Okay, this is often given insufficient attention when choosing the best transducer for a particular measurement. तो ये क्या कहते हैं कि भाई पर्टिकुलर जो इंस्ट्रूमेंट है हमें उसके लिए एक प्रॉपर एनवायरनमेंट सेट करना पड़ेगा, क्योंकि कुछ इंस्ट्रूमेंट्स के अंदर इतने सेंसिटिव इक्विपमेंट्स है, अगर उससे ज़्यादा हम मतलब गर्मी के एटमॉस्फेयर में रखेंगे, ज़्यादा ठंडी के एटमॉस्फेयर में रखेंगे, सो इट विल बी going to affected that measurements. Okay, so that transducer response is might be going to be affected due to the environmental conditions. Okay, now the performance of the transducer is fully defined by its transfer function and error, provided that the transducer is in constant environment and not subjected to any disturbances like stray electromagnetic and electrostatic fields, mechanical shocks and vibrations, temperature changes, pressures and humidity changes, changes in supply voltage and improper mechanical mounting. So these all are the parameters that's going to be affected your response of the transducer. Okay, students, so what it will be says that if there are an electrostatic fields are there, if suppose your transducer is placed and nearly one more electrical instrument is going to be placed over there, and दूसरे जो इलेक्ट्रिकल इंस्ट्रूमेंट है उसका जो स्टैटिक फील्ड आपका ट्रांसड्यूसर को भी अफेक्ट कर सकता है. सिमिलरली if your transducer are placed if it is placed on that, if continuous mechanical shocks will be there, मतलब कि कोई वाइब्रेशन कंटिन्यूसली आ रहा है, कोई मशीन ऐसा है जो कॉन्स्टेंटली वाइब्रेट कर रहा है, उसके नज़दीक में अगर आपका ट्रांसड्यूसर होगा तो उसके कारण भी आपका ट्रांसड्यूसर का रिस्पॉन्स में चेंजेस आएगा. सिमिलरली for the temperature changes, as I discussed, for the pressure and humidity changes, these all are the parameters that is going to be affected to your transducer responses. Okay, now if transducers are subjected to the above environmental disturbances, the changes in transfer function and resulting errors therefore do not occur, and therefore the transducer selected must be guarded against the interfering and modifying inputs. Okay, so whenever you are selecting the transducer, you must have to select according to your requirement and place at proper place where it is not going to be affected by environmentally or by not affected by the mechanical shocks, so that that conditions will give you a proper result and your transducer response is going to be give you an accurate result. Okay, students, so today in today's lecture we will discuss up till that, and further part we will discuss in next video lecture session. Okay, just a moment. So students, finally, as in every lecture, after completion of every lecture, I will try to give you a message that please remember turn off the light when it is not required. Okay, so please save the energy, save the electricity. Thank you very much.